Hi students, let's see about series RLC circuit analysis when you are giving AC circuit as an input. So here we are giving AC circuit as an input, which is V is equal to Vm sin omega t, and all the three components here we connected, which is RLC, and all the three are in series. So whenever they are connected in series, the voltage gets divided and the current remains same, which is I. So the current in the circuit remains always same. Let's see the voltage drop across each components. According to Ohm's law, V equivalent to IZ, because here we are providing AC input. So when you are providing the AC input, instead of R, the impedance we need to consider. So V is equivalent to IZ. Voltage drop across R, VR is equivalent to IR. Voltage drop across L is VL, which is I into XL. Voltage drop across C is VC, which is I into XC. So VR is equivalent to IR, VL is equivalent to I into XL, and VC is equivalent to I into XC. These four equations plays a major role. Based on that only we will be doing all the derivative parts. The next one, we need to go for the Phasor diagram or voltage impedance triangle. Only one case we are considering, which is XL is greater than XC. We can consider the XC greater than XL also. But here we are taking only XL greater than XC. So take VR, VL minus VC, whichever is a larger one, means higher value you are considering, that voltage you need to take. So VL minus VC, and here the input voltage VM, means input voltage gets divided across all the three components R, L and C. So from the triangle, this is based on the voltage and this is based on the impedance triangle. This is known as impedance triangle. Based on the impedance value across all the components, we draw the same. Okay. Then how to find the impedance value? Everywhere you just go through these triangle. After just looking these triangle, we can derive all the equations. So from the triangle, Vm square, use Pythagoras theorem. So Vm square is equivalent to Vr square plus VL minus Vc the whole square. Vm square is equivalent to Vr square plus VL minus Vc the whole square. Now substitute all the equations for Vm, Vr, VL and Vc. We know Vm is equivalent to I into Z. So I is the whole square. Vr is equivalent to IR the whole square. VL is equivalent to I into XL. And Vc is equivalent to I into Xc the whole square. All these equations initially also we are considering what is the voltage drop across the R, voltage drop across L, voltage drop across C. From this we need to take the values and substitute here and take I as a common. I square as a common value if you are taking, you will get only Z square is equivalent to R square plus XL minus XC the whole square. So what is the impedance? Take square root, which is root of R square plus XL minus XC the whole square. This is impedance value. And next we'll find out what is phase angle. Take the same triangle. From this triangle only we are deriving all the values as I told you. Phase angle is nothing but the pi value. What is the angle? Whenever the current enters into that circuit, the current lags or leads. That angle, phase angle we need to consider. What is the phase value? Is from the tan pi value. Tan pi is equivalent to, from the triangle, what is tan pi? VL minus VC divided by VR. So tan pi is equivalent to VL minus VC divided by VR. Again substitute all the values. What is VL? IXL. What is VC? IXC. What is VR? I into R. Now take I as a common value. If you are taking I as a common value, I into XL minus XC divided by I into R, we will get I will get cancelled. So XL minus XC divided by R. But we want only the phase angle pi. So pi, if you want from the tan pi, take tan inverse of XL minus XC divided by R. And next value what we are going to derive is power factor. Power factor is nothing but the cos pi. Again take the same triangle. What is cos pi from this equation? We need to find out cos pi. Cos pi is VR divided by Vm. So cos pi is VR divided by Vm. Again we know VR is equivalent to IR. Vm is input voltage, which is equivalent to IZ. I will get cancelled. So what is cos pi? Cos pi is R by Z. Already we found what is Z. Z is equivalent to root of R square plus XL minus XC the whole square. So just substitute here R by root of R square plus XL minus XC the whole square. You need to go through the phasor diagram also. That is also very important. Thank you.